We are solving another very frequently occurring concept for JEE 2026, which is effective power of a lens combination. So let's dive directly into it. Now we will solve all the remaining questions of optics starting from 22nd January morning shift, question number 33. You can pause the video and read the question for yourself. I will give you a gist of the question. They are asking us to find the effective power of this combination where we have a concavo-convex lens immersed in water. Okay. Now the upper portion of water is forming a plano-convex lens, and the lower portion of water is forming a plano-concave lens. Okay. So it's pretty straightforward question. Let's directly dive into the solution. First step is to draw the three individual lenses. The two lenses made up of water, these two, and the one made up of glass, the middle one. Now, the very first mistake I want to address that students make is they assume that water is surrounding medium and the concavo-convex lens is the only lens. Why this is wrong? Because water is not the surrounding medium. Anything will be considered as a surrounding medium only if it surrounds till infinity. The medium should extend till infinity, whereas the water here in this question, it is having a very limited range, right? It is not extending till infinity. So I will not be considering water as the surrounding medium. The second mistakes that students may make is the sign of the radii. So now that is why I have drawn each radii and I'm going to explain why which one is positive and which one is negative. So note the direction of incident light. The incident light is moving downwards. So we will use the normal sign convention. Opposite to incident light, all measurements will be negative. In the direction of incident light, all measurements will be positive. So question is very straightforward. Since here lenses are in contact, the effective power will be the sum of their individual power. P effective is equal to sigma pi. So let's just add the power of all the three lenses. Now you see for the first lens, the upper surface has infinite radius of curvature because it's a flat surface, and the lower surface I have taken the radii of curvature as negative in the lens maker's formula. Why have I done that? Because if you see the the lower surface, its center of curvature is above. So your radius of curvature will be measured from down to up, but the light is going from up to down. It's going against the direction of incident light, so I'll be taking it as negative. Similarly, if you see for the second lens, the concavo-convex lens, again both the radii of curvature I'm taking them as negative. For the same reason, if you see the center of curvature, their center of curvature lies above the lens, whereas light is going downwards. Similarly, here R2 is also negative, which is the third lens's upper curvature, because its center of curvature is upwards and light is going downwards. And the second surface of the lowest lens is flat, therefore its radius of curvature is infinity. Now, if I substitute the value of refractive index of water to be 4 by 3 and that of glass to be 1.5, we will end up with these four terms only. So all you need to do is do simple arithmetic and you're supposed to end up with minus 1 by 6 into R1 minus R2. We are solving question number 26 from 22nd January evening shift. A symmetric thin biconvex lens is cut into four parts by two planes, one horizontal, one vertical. The power of one divided part is. So the question is very clear. There is a biconvex lens which I have drawn over here. We have cut it into four parts by horizontal and vertical planes. And here I have drawn the separated diagram of one of the parts. So what we are going to do is we are going to write the power of the initial full lens and power of the cutout part, and we are going to divide them because we need to determine the power of the cutout part. Now power of the first lens is mu minus 1 into 1 by R1 minus 1 by R2. R1 is a positive R here because its center will be to the right and light is also going to the right. Whereas the left curvature center will be, the right curvature's center will be to the left, but light is going to the right. So R2 is minus R. So 4 diopter will be equal to mu minus 1 into 1 by R plus 1 by R, which will become 2 by R. Now for the second lens, you can write mu minus 1 into 1 by r minus 1 by infinity, because the second curvature is basically flat, so its radius is infinity. And you see that P2 is mu minus 1 by r. So if we divide these two expressions now, P2 divided by 4 diopter is equal to half. That means P2 is equal to 2 diopter. Alright students, let us end our today's session here with this homework question. The question reads, what is the relative decrease in the focal length of the lens for an increase in optical power by 0.1 diopter from 2.5 diopter? You have these 4 options. Kindly solve this and comment your answer in the comment section. Thank you for watching this video.